Okay, now is the final chapter of the, let's say, the basic of ROS. After that, we will be now entering the part of coding. We will be looking for publishers, subscribers, service actions, parameters, a little bit of ROS Doctor. That is the debugging tool of ROS 2, and how to create a simple plugin. But first to the basics. Let's move and explain what is a package. Well, a package is a resource of where you organize your ROS code. As in previous lesson, you saw that we have in the source folder everything related to other applications like the turtle sim that we modified, and in that way is the recommended option that the ROS developers use to organize its code. So, for example, let's move to see what is inside a package. Cd source, ls, cd ROS tutorials, ls, cd turtle sim, ls. Okay, let's bring in a better way. ls, lash. Okay. The main things here are the CMake leaks txt. That is the file that you CMake to build your application. The package XML, the source folder, the package XML is where everything related to your ROS dependencies and executions and everything goes. And the source is where your ROS code lies in. So for example, let's move to the source folder. See the source. Okay, for example, here in the source folder, you will see the same information about the package. Sorry, the source files that you will use to construct your application, for example. What kind is practically that in that way. Another thing that I don't mention, and you will see when we will our first package, is where are located the header files and the application files and launch files and so on. So let's build a package. So let's move on. Okay, let's delete everything over the source folder, and let's delete everything about the build, the install, rf build, install, log, source, everything that is inside source. Okay, it's clean. Now let's build a package in two versions. Let's build a package in C++, the workspace using C++, and the other workspace using Python. So for that, let's move it a little bit higher. This is ROS2 package create, and the build type is ament CMake for using C++. You can specify the license, for example, Apache 2.0, and the name of the package. I will say my CPP package. Okay, in this way, you will see that you have the package, the CMake list include where goes your header files here in C, license, the source. Currently, there is nothing inside. That's why you don't see anything inside these folders and nothing inside source. Now let's build the same thing but with Python. For example, another thing that you noted is I put myself inside the source folder to create a package, right? So remember that when you build something, you go to the root. The root in this case is ROS2 CLI workspace. And when you create a package, you put it on the source. Don't mess everything because it will be a confusion later, and you probably will not like that in your environment. So for here, let's build a package in Python. My Python package. Okay. And let's move to the CD, my Python package. Move to the tree. You will see here you have an initialization init py for if you want to init something, the package XML, where some resources are, set up configurations for Python and for launching the package, and some test files that will be easy to follow when you use your package. So for now, let's, for example, see how we build the entire workspace here. Remember, go to the root, do colcon build, and this will build both packages, the Python version and the C++ version. And of course, you will have here your package build because practically we did nothing. So in this case, let's run the package that we are using about, for example, the C++. Let's see if we have something here. I think it will not work. CD source. Let's see something. C my C source. Okay. Okay. This is only the case that you build a package and how to compile it using colcon. Currently, there are no sources. We didn't compile anything. We didn't specify nothing but our CMake list, so it will not run any node. But let's see what's inside the CMake list. Cat CMake. Okay. Inside the CMake list, you will see that you have the minimum required version that CMake runs, the project name, and the compiler options. And if you for example, you require something or some package to be found, you specify here the build settings and the how to build the ament package. On the case of the package XML, you will saw that again you have the name of the package, the version that you're using, the maintainer, here, sorry, the maintainer, the description of the package, the license. Here you specify the dependencies of the package or the build tools depend, on the execution depends, everything that you will be seeing later on the when you write your notes about publishers, subscribers, and so on. Remember that previously we did everything via command line interface tools. Now, after this chapter, let's say, or video, we'll be using C++ and Python to specify the same thing that we did with the command line tools, but programmatically. What kind of information I can say you? No, nothing more. It's just simple as that in that case because we didn't build anything. So, for example, if you have problems compiling, usually is related to the CMake list and the package XML. So you have to validate your CMake list, the format, and if the package names are that you are finding are correct or not, because usually the problems comes in those two sources. And also you will see in Python is a little bit different to build the package. Usually you start using Python, but I recommend you to use C++ in the case of robotics because it's very powerful, and yeah, every kind of application mostly are done in C++. Not only the versatility, but also the speed. And for example, there is a just a case about you can go directly to Python. For example, if you are in the deep learning part, I recommend you to stay in Python because usually doing things in AI using C++, probably you will have to port so much code to C++. So practically, let's say that the deep learning models and the AI stuff you can keep in Python and mix it over the nose using C++ and so on. But it depends on your application and what you like to use. So that's all. Let's move again to the next chapter, that is publishing, doing simple publishers in C++ and later in Python. Oh, sorry, I didn't remember to tell you something. Let's see the Python package. So let's see the package XML. Is, as you see, is practically the same in terms of format. It's an XML file, but let's move and see the setup.py and the setup.config. Here, practically you will stay it the same. It only describes the libraries where are located for Python and the style script where are located. But the main difference here is the setup.py. Here, let's put it a little bit. Here, for example, you see the package name. When you want to locate the package later, you will see that here in the data files you put where to locate the launch files, where to locate other source package that are inside this uh, Python package. Sorry for the redundancy. And here on the entry points, you will specify your console scripts in the terms of the main files that you are trying to launch or your node in this example. So that's the last thing I wanted to you to know, and that's why I make this short video again to expand the definition of using Python over ROS. So that's all. Thank you.